So good evening everybody, my name is Anita, I work at the Austrian Research Center for Forests, and today I will be presenting our project AI from Trees. To start off, I want to give a quick information on our project details. So our project started in April of last year, so we just reached our 1-year milestone, and if you have worked with a lot of data, then you know a lot of effort is put into the data preparation. Hence, for today, I will not be presenting as many results, but more of what we're going to do and what we're trying to do. And I'm very happy to get some inputs on our plans. So the total runtime for our project is 3 years, and the main goal, as mentioned in the title of the presentation, is to build a model that predicts tree growth really, really good. And with tree growth, or every time I mention tree growth within the presentation, I always refer to dBH because this is the parameter where we have really a lot of data to work with. We have quite a few side goals for the project, and these arise because we have project partners in really different fields. So we have a project partner that is specialized in AI. We have project partners that are specialized in TLS, in Earth observation data, and different types of model building. So some of our side goals I will mention throughout the presentation, but to give an example, we want to compare the final AI model with a statistical model that we're deriving in parallel. Then we also want to find some algorithm to calculate single tree competition automatically from the TLS data we're obtaining. And then what is very important to me, because at the moment I'm doing the data preparation, we also want to optimize data preparation using AI techniques. To give a quick overview on our data, so the growth data we're using for the analysis is obtained as part of the ICP Forest monitoring program. If you don't know it yet, ICP Forest is a European-wide monitoring network, so similar data that we have for our analysis is probably also available in your country if you live in Europe. And you can contact the country responsible person via the ICP website. So for Austria in total we have 16 ICP forest plots that you can see here on the map. And we have 16 normal plots, and then we have 16 so-called core intensive monitoring plots where we just obtain more data. So for example, here we have weather stations within the stand. We have different measurements on soil, so soil temperature, soil moisture, but also chemical analyses that are done in a really high frequency, like for deposition it is 2 weeks, and also the soil water chemistry is also analyzed every 2 weeks. For my presentation, I will be focusing on the stuff that we are doing with the data from the 6 core monitoring sites, and what is really nice here is we have only single species stands, and the species we have at the stands is spruce, beech, or oak. The growth data that we have within the project we classified into 3 different types. So we have high frequency, mid frequency, and low frequency data. The high frequency data is obtained by dendrometers, so these are hourly measurements of tree diameter change, and you can really see changes in the diameter because the measurement device has a really high resolution. So for each of the 6 core plots we have around about 10 trees that are equipped with the dendrometers, and from 2011 on we have measurements each hour. So we have about 10 years and 60 trees where we obtain the hourly data, which is really nice. Then for the mid-frequency data, we have 20 trees per plot. So as you can see, as we go lower with the measurement frequency, we have increased the sample size. And also from 2011 on, we're manually measuring tree diameter or tree circumference every other week. So a site manager is going there every other week and obtaining this value. For the low frequency measurements, we have approximately 100 trees per plot, so this depends on the stand structure and also the tree species. And we have those at the 6 core plots, but also the other normal plots that we have within ICP in Austria. We started collecting this data in 1994, and we do measurements every 5 years. not only on DBH, but also tree height and social status of the trees are evaluated. Other data sources we are using within the project is the TLS scanning, as I've mentioned before, as well as Earth observation data and other ICP forest data sets. And to that I will come now. So part one of our analysis is the high frequency growth data, so the one that we obtained from the dendrometer. And what we're planning to do is we're planning to use different model types to model the growth data. So for the AI part, we decided to use long short-term memory, so LSTM, and then for the statistical modeling, which I am doing, I will try to use different approaches, and of course, we will then compare which model is better, and also the learnings we get from the one model we want to use to improve the other model. The data input we have here, so of course the dendrometer has hourly measurements, so we need data input in a similar measurement frequency, and at the stands this is mainly the climate data we have, as well as the soil data, soil moisture and soil temperature, and as far as we are now with the analysis, we saw that really the soil temperature and soil moisture are really the great parameters to work with for now. What we can do, or at least what we are at the moment aware of that we can do, is to predict growth for individual trees. And I tried to visualize this a bit with the picture on the upper right you can see. So for each stand we have one measurement station that obtains climate data and soil data, and then we have the 10 different trees with the dendrometers, and as you can see in the picture, the trees maybe are of different size, they're in different competitions, they maybe also have different soil conditions, so it is not possible from one measurement to obtain 10 different values. So naturally the growth of the different tree individuals will also differ. But what we hope to get from our model, or the main output of this model, should be an idea of how we can predict the growth onset and the growth offset based on climate data and soil data, as well as then the duration of the growing period. And what we are also hoping to do is to identify bad and good growing years. So for this model, as I mentioned, we only use the climate data and the soil data, and this is really nice because the climate predictions are, of course, always for the meteorological data, and so we also hope to get an idea of how the distribution of good and bad growing years with climate change will maybe change in Austria. And at best I tried to sketch what our output will be. So we have the model here in black or green, and then we will have some trees at the stand that have just, so this is now one here that we're looking at. We will have some trees that overperform the model in terms of growth, and then some trees that underperform the model. Moving on to the next part, the terrestrial laser scanning. So the image on the upper left is a screenshot from a video that we did, so where you can really fly through the forest and see a lot of details in the stand, which is really interesting. And what we're trying with the terrestrial laser scanning really is we want to extract competition parameters or combinations of competition parameters automatically from this TLS data. Also, we want to compare, of course, the accuracy of the TLS to the manual measurement, not only in terms of the measurement accuracy, but also in terms of labor, because, of course, the TLS is done really quickly in comparison to if you do it manually, but then you have to pre-process the data, and that can take quite some time. What we also want to do with the mid-frequency measurements, I already mentioned, is we want to create a model that only takes into account the competition, and there we hope to see how far we can go really with one TLS scan. We're doing the TLS scans at all the 16 ICP forest stands, but at the 6 core plots we're doing them annually, so we will also be able to track the changes in tree diversity and compare those to the manual measurements and even the dendrometers. We want to get quite creative with finding competition parameters. Of course, we will use some from the literature, but on the right side you can see an idea that we had to use. So for example, the red ones, you can see the crown projections, and what we did here is we added a 1 meter buffer zone, and now we're analyzing the overlap. So is there overlap in which direction, and is there maybe also no overlap where the tree, on one side there is overlap, on the other side there's maybe no overlap, so the tree can also expand in a different direction. Then we also want to use the TLS data for the analysis. So you already saw the little sketch on the upper left. So we have the over and the underperforming trees, and we want to see, okay, what do these trees have in common? If all goes well, then we would see the trees with better growth have lower competition, and the trees with worse growth have lower competition, but then also it comes down to which are the competition parameters that we can really use, and which are the important ones, which one should we focus on. Finally, of course, the end goal for the project is to have a really good model to predict tree growth. And as I mentioned, on the one side we now have the only TLS-based model, then we on the other side have the model that only uses the automatically collected data, so mainly climate data. At the end we want to combine these approaches and find a model that contains both data sources, and this model will be trained on the high and mid-frequency data that we obtain. To finally test our model, we have the low-frequency data I mentioned at the beginning, so you can see the tree numbers maybe, they are very small on the left side, but it's around about 100 trees per plot. And we just want to use the model, this data for the final validation of the model. Also, as I mentioned before, we also have ICP forest sites in other parts that we have not used in the analysis yet, and we also want to test our model on these sites to see if we have a model for spruce, can we also use it on a different stand, or how big is the error that we should expect from it. Of course, within the project we also have a dissemination work package. So if you're interested in the project, you can follow it at ai4trees-project.at, and we're also very, very active on the LinkedIn. And I have one more minute maybe, I can also show the full video that we obtained from the TLS data, so that you can also get an idea of the stand. So this is a beach stand in Klausen-Leopoldsdorf in Lower Austria, and so now in this picture you can see a really small tree that we would not detect in the normal inventory. You can also see the dead wood on the floor, and even you can see here now our litter fall collectors, and I think it's just a really nice way to also showcase the forest that we're working in. But that's it from my side.
Okay, thank you.